Hi, so now we're on page 7. We're getting there. Probably more of interest to you now are things you might have forgotten a little bit more. We defined on the last one the three axioms of probability. Using those axioms, there's lots of other facts we could prove. For example, I use this a lot. Probability A plus probability A complement is 1. So sometimes when you want to find the probability of one thing, it's easier to find the probability of the other, its complement, and then subtract from 1. Also, probability of empty set is 0. And this, I think the main point of this page is probability of A union B is the probability of their sum minus the intersection. So what I'm really doing, if I put like numbers in these, here's number 1. Oh, you could hardly see that. Well, red and orange. Well, let's just go this way. Probability of so I'm trying to find probability of A union B. Okay, so that's all of the red, orange, and yellow. Probability of A would actually be the yellow and the orange, so it's this region right in here. Probability of B would be the red and the orange, so it's this region right here. So you can notice that I double counted this orange in the middle, so I have to subtract off that intersection. So that's how we find probability A union B. If the events were mutually exclusive, the intersection is empty and the definition still works because this would be 0. So I have a couple of examples. Let A be the event that a Rose-Hulman student has an American Express card. B, they have a Discover card. Let's randomly choose a student. Suppose the probability that they have an American Express is 0.2, 0.7 that they have a Discover. The probability they have both is right here. So determine the probability a student has at least one of these two cards. At least one is probability of A or B. So we're looking for that. So simply I add probability A plus probability B and subtract off the intersection. So that's a pretty easy case because you have everybody given to you. A lot of times it's nice to draw a Venn diagram or a 2x2 table. I actually prefer a 2x2 table because Venn diagrams, people sometimes label the circles wrong and then they can make mistakes. So maybe I'll draw one up here for this case. Assume a visit to a dentist results in a cleaning or a root canal or both. That could be a really bad day for you. The probability of a cleaning is 0.8. So let me draw this 2x2. So probability of cleaning not. And the other thing is probability of a root canal and probability of a root canal not. Okay, so there's my 2x2 table. The probability of a cleaning is 0.8, so I'm going to put 0.8 here. And so that means the probability you're not going to get a cleaning is 0.2. Probability of a root canal is 0.2. Probability of not a root canal is 0.8. The probability that you get both is 0.1. So this is root canal and cleaning. Find the probability of the following. So there's my 2x2 table. You go to the dentist, what's the probability you get at least one of the above? So actually I might as well fill in this table. I know this has to be 0.7 because they add up. This has to be 0.1 and this has to be 0.1. So what's the probability that you get at least one? So that's the probability of a cleaning or a root canal, which is just the probability of a cleaning plus the probability of a root canal minus the probability you got both of them, which is 0.9. Okay, what's the probability that you get a cleaning but not a root canal? So just a cleaning and not root canal is right here, right? Cleaning and not root canal, so 0.7. That's the probability of a cleaning and root canal. Wow, I hope I haven't been interchanging, but complement, sometimes I forget and I put like little dashes. That also means complement in some books. What's the probability you receive neither? So there you are right here. That's the probability of a root canal or cleaning not and root canal not, which is 0.1, or that's the probability of a cleaning or root canal not, which is also 0.1. Either way, by De Morgan's law, these are the same expression. And last question. If you go for an appointment, is getting a root canal and cleaning mutually exclusive? No, because you could have both done. So that would mean the intersection is empty and it's not. So are going in for no, both could happen. I mean, I doubt it in today's age that you'd have to have both at the same time, but it could happen. I think I'll end it there. So there's the probability of the union of two events.